Hello Year 10. This is part 1 of your density core practical. So I'm going to run through the practical with you and you are going to write down the results that I measure, and then you're going to calculate the densities of, I've got 4 different materials here. I've got Perspex and I've got 3 unknown metals, which I'll come to in a minute. Right, this is part 1. This is measuring the density of a regular shaped object. Okay. Now, just to recap, to calculate the density of something, we need 2 values. We need 2 quantities for the material. Well, density equals mass over volume, so we need to measure the mass. That's where the top hand balance comes in, and we need to measure the volume. That's where the ruler comes in. Now, because it's a regular shaped object, we can, and in this case they look like cubes, we can measure the width, the length and the height, multiply them together, and that gives us the volume. Now, for measuring the width, the height and the length, we could use a regular ruler. Now, this can measure to the nearest millimetre. That's called the resolution of this ruler. Okay, the resolution of a measuring device is the smallest increment it can measure. So in this case, this ruler can measure to the nearest millimetre. This top hand balance, if you see, can measure to the nearest 0.01 gram. So that's the resolution. The resolution of the top hand balance is 0.01 grams. The resolution of this ruler is 1 millimetre. Right, we can do better than the ruler though. We can go to a higher degree of resolution if we use something like this. Now this is called a digital caliper. Okay, now this can measure not to the nearest millimetre, but I hope you can see it can measure to the nearest 0.1 millimetre. That's going to give us a more accurate measurement for volume. Okay, right, so I'm going to run through. You're going to write down the measurements as I take them, and then you're going to calculate densities. So the 3 materials we've got Perspex. Now we've got metal A, metal B and metal C. Your job is to calculate the densities of all the 4, but with the density of A and the density of B and the density of C, I want you to find out what they are by looking up the density of metals, the densities of a range of metals on the internet. I'll give you a little clue. These 3 are elements. Okay, they're metals, they're elements. But if you can calculate their densities correctly, you should be able to match them with known densities off the internet. So let's get started with the Perspex, easy one to start with. Right, looks pretty neatly cube shaped. So we have the length 20.1 millimeters. The height, 19.7. The width, 19.1. Now the mass of the Perspex, right, we need to zero this, don't we? Because it's reading minus 0.04, so we're going to zero it. And then we're going to pop it onto the top hand balance. So Perspex, the mass, look at that, bang on, 9.000 grams. The 00 is important, because if you just write down 9 grams, you're saying I measured it to the nearest gram, but we're not. We're measuring it to the nearest 0.01 grams. That's important. So there you go. Perspex, done. Right, metal A. Okay, metal A. Right. Length, 19.8. Width, 19.8. Height, 20.5. There are your measurements. The mass in grams, 88.71 grams. Write that down. That's A. Done and dusted. Right, on to B. Metal B. Width, 20.0. Height, 19.2. Width, 20.1. Okay. The mass of B, 21.40 grams. B, done and dusted. Last but not least, we have metal C. Okay. Width, 20.0. Height, 19.8. Length, 20.0. And finally, the mass in grams, 71.15 grams. Right, it's down to you now, guys. Hopefully you got those measurements written down. What I want you to do now, calculate the volume, calculate the density. So density of Perspex and then density of A, B and C. Do a bit of internet research and see if you can tell me what A, B and C are. Thank you.